This is the result of the coding project I did. What you see is Mega Tic-Tac-Toe played by two dumb AIs that just make random choices. In this video I will show you steps I did to make this. Alright, so I started by making regular tic-tac-toe. I needed a way to store the board. First I made a two-dimensional array of nullable booleans where true is a cross, false is a circle, and null is an empty spot. It wasn't really the nicest way of doing things. I also needed a way to display it. I created a drawer class which makes lines and circles. I had to have a way to add a figure when the user clicks on the screen, but only when they click on an empty spot. I also needed a way to display the figure. And finally, I made a method which checks if someone wins or if it is a tie. I spent way more time on this than I thought I would. It took me over an hour to get everything working correctly. This is the result. After making regular tic-tac-toe, I tried to start coding the ultimate tic-tac-toe. But after a while, I realized that my code is an absolute mess. So I created a small grid class, which holds a regular tic-tac-toe board, allows you to add a figure, displays the board with the figures, and checks if someone wins. But I also created a game manager class, which saves whose turn is it, handles the click, and does other similar things. Two-dimensional array of nullable booleans is now a two-dimensional array of nullable figures. Figure is my new enum, either cross or circle. I also added a game time enum, which is either small, big, or huge. Additionally, I added a status enum, which is either nothing, cross win, circle win, or tie. The code was fixed and I could start coding the ultimate tic-tac-toe. But before I show the coding of the ultimate tic-tac-toe, I will explain the rules to people who don't know them. You start with a 3x3 grid and then place 9 smaller 3x3 grids inside of it. The game starts in the small grid in the middle. The first player puts their figure anywhere in this small grid, and depending on where they placed it, the next player has to place their figure in a corresponding small grid. If the first player puts their figure in the top left corner of the middle small grid, the next player puts their in the top left small grid. Then the situation is reversed. Depending on where the second player places their figure in the small grid they were forced to place it in, the first player places their in a corresponding small grid, and the game continues like this. Now when someone wins in one of the small grids, the big version of their figure will appear covering the small grid. After this, the game continues normally. The player who won doesn't get another move, and in this case the second player will be forced to put their figure in the middle small grid. Now, if a player gets sent to a grid in which someone has already won, or there was a tie, they can place their figure anywhere, without restrictions. The game ends when someone wins with the big figures, or when all of the small grids games are finished. So I started coding the ultimate tic-tac-toe by making a big grid class. It is really similar to a small grid class, but with some things changed. The big difference is that rather than having a two-dimensional array of nullable figures, it has a two-dimensional array of small grids. It has a method to draw itself, but with thicker lines than the small grid class. It has a method to add a figure, which just calls an addFigure method inside the chosen small grid. It has a method to draw a cross or a circle, just like a small grid class, but this time it draws the big figure that covers up the whole small grid. It also has a win or tie detection, which is almost exactly the same as in the small grid class. I also had to add some logic to the game manager class when it comes to saving in which small grid you can place a figure. Additionally, I made some changes to the small grid's drawing method and figure drawing method so that small grids inside the big grid draw themselves correctly. It took me a while and I was really happy when it finally worked. However, it is quite annoying to play because the app doesn't highlight the small grids where you can place your figure. As you can see, everything works correctly. So now, before I show you the coding of the Mega Tic Tac Toe, I need to explain the rules, since it is a game I created myself. So you start with a 3x3 grid and place 9 smaller 3x3 grids inside of it, and each of them you place 9 even smaller 3x3 grids. And the rules of where you can place are different from Ultimate Tic Tac Toe. So now, when someone places here, to tell where the next player has to play, you just look at the big grid the figure was placed in. You then look at where the figure was placed inside of this big grid. In this case, it was placed in the top right small grid and in its left spot. So now we go back to the huge grid, and first we go to the top right big grid and then to the left small grid, and that's where the next player has to place their figure. If you get sent to a small grid where the game has ended, you can place anywhere in the big grid the small grid was in. Only when you get sent to the big grid that the game has ended in, you can place anywhere you want in the entire huge grid. So I started coding the Mega Tic Tac Toe by creating a huge grid class. It has a two-dimensional array of big grids. It has a method to draw itself, but with even thicker lines. It has a method to draw a figure, but an even bigger one than the big grid class. It has a method to add a figure, which once again just calls an add figure method inside the chosen big grid. And it has a win or tie detection, which is exactly the same as in the big grid. It was quite easy to make. The second thing was to make some changes inside the big grid and small grid classes to make them work inside an even bigger grid. It also wasn't hard. The real challenge was making the logic in the game manager. Checking if the player can place a figure in a spot they clicked on required an extremely long if statement. It was also hard to choose which small grid is available next. I couldn't get it to work, and it was pretty late, so I had to sleep. But the next day, less tired, I quickly did it and was very happy with the results. But there was one problem with the app. It didn't highlight the grid you can place your figure in, so it was really hard to play. So I started working on a way to change the color of the lines to tell the player where they can place. I couldn't get it to work for a very long time, and when the lines finally did change the color, I realized that I did everything wrong. So I then redone it and I highlighted correct lines. But there was another big problem with the way I drew the lines. No matter where the small grid was, I always drew the horizontal lines, for example, from the left edge to the rightmost point of the huge grid. So then, when I would change the color of this line, it would be blue all the way from the left and to the right, not only in the small grid I wanted to highlight. Same for vertical lines, and also the big grid's vertical lines and horizontal lines. So I had to change all the methods for drawing the small grid and the big grid. And after all of that, it finally started working. So the last thing I did was make the AI. I created the AI class and added 3 methods. I first made make small grid choice method, which just selects a random free spot inside of the small grid. Then I made the make big grid choice method. It was a little bit more complicated. If the AI could place the figure anywhere in the big grid because the player sent it to the occupied small grid, it would first select a random free small grid and then call the make small grid choice method on it. Otherwise, it would just call the method on the one small grid it was forced to play on. Finally, I made the make huge grid choice method. If the AI could place the figure anywhere in the huge grid because the player sent it to the occupied big grid, it would first choose a random free big grid and call the make big grid choice method on it. Otherwise, it would just call the method on the one big grid it was forced to play on. I also had to make some big changes to the game manager class to support the AIs making choices and also an option where they play together. I was really happy when it all started working. Okay, so this is the last part, commenting the code. All the other parts with the coding were sped up 60 times. This one is sped up 20 times, so I have the time to talk about a couple of things. First, about this project. So with the commenting, it took me 8 hours total over 2 days. I started on Friday and finished on Saturday, but on Saturday 4 weeks ago. I was making this video on the course of 28 days, not because I was lazy, but because it is hard to find the motivation to make these voiceovers and bad paint animations when I have to focus on school and learning, especially since very little people watch these videos. And that's where I get to the second part, about the programming videos. I got some motivation when one person subscribed to me, and when I looked at their channel in the subscriptions tab, I found other programming channels and no other Celeste channels, so they subbed me because of my programming videos. This motivated me a lot, and without it I might have not finished this video at all. So I probably will release some other programming videos. I have a lot of ideas. I thought I would start working on Minesweeper, but I changed my mind. I started working on the Carcassonne game. I made the tiles functioning. You can place them on screen, only in the correct spots, in correct orientation. However, I stopped there. I lost interest. I started working on the cards library. I wanted to make a library with classes, so that it is easy to create any card game you can think of with it without very much work. From War to Macao, from poker to bridge. Not that I am an expert in card games or something. So I'd like to have a table class, where you would be able to add some spots for the cards, and then add players with hands, and then have some way of comparing the cards quickly. But I didn't even start, and I already got bored. So then I started working on a sorting algorithms visualization. I made some stuff, but didn't record the coding process, and it wasn't really that complex. I just did quick sort and bubble sort. So then I started working on Celeste top 10 players visualization, just like the Cube Rolls channel did for the speed cubing records. But it also didn't really go anywhere. And I have some other plans for the future. Maybe make a logic gate simulator. Maybe make an adventure game in console. Maybe learn to use a graphics library. I would also want to do a simulation game where there is a world and there are people in this world, and they use the materials in this world to create a self-sustaining civilization. But then I wonder, do I have enough knowledge about C# to make things like this? The way I program is similar to the way I speedrun Celeste. I learn about C#, then I do projects, then I realize I can't do more advanced projects without learning some new things about the language. So then I repeat. Same with Celeste. I learn some strats, then I do full game speedruns, but then realize that I can't improve more unless I learn some new strats. So then I repeat, and that brings me to the third topic, Celeste. I will continue making Celeste videos, although I had a longer break. I got the interest in the game again. Also, I really need to buy some additional things for the microphone I use. I mean, the quality of my videos when it comes to sound is really bad. And it is way more enjoyable to watch a video when you can actually understand what the person in the video is saying. Okay, that is everything. Thanks for watching, especially if you made it here. I didn't ask for likes before, but I would really appreciate it, because this would let me know someone actually enjoys these videos. Bye.